Hey guys, it's Miss Etheridge. Just want to help you out a little bit on your Tuesday assignment, your workbook. I am on page 83 in your Practice and Problem Solving book. So let's look at our example problem and see what we're working with. So it says Monty and Ramon are each saving all the money that they earn. Monty started with $3 and earns $8 an hour at his part-time job. The graph shows Ramon's total savings. Which function has a greater rate of change? All right, so it tells you right here, this is Ramon's savings. It says make a table of values for Monty's savings. So here we've got Monty. So at hours worked 0, he had a total savings of $3. So that means that he had $3 to start with. All right, and then Ramon already had $6 to start with. All right, let's look. They give us all our information. They've done the work for us. It says that Monty's rate of change, so our table, the vertical change is 8 and the horizontal change is 1. So if you look right here, every time this is going up by 8, and then up top, the X, every time it's going up by 1, so that's where they're getting the 8 over 1. All right, it says that you can use the graph to find Ramon's rate of change. So we're still looking at vertical change over horizontal change. Remember, we can also write that as delta Y over delta X. So any 2 points, we can check it. I'll just go from here to here. But if we go up 1 unit, that's 6, and then over 1, okay, that's 1 hour worked, so $6 per hour, where Monty was making $8 an hour. So it says the rate of change for Monty's savings is greater. All right, it says what, number 1, it says what do the rates of change represent? Well, if you look at your units, it tells you right there, it says $8 per hour, $6 per hour, talking about total money and hours worked. So the rates of change are the hourly wages. So hourly wages, okay. So, or the amount of money earned per hour. All right, then number 2, it says, what does it mean in the context of the example to say that the rate of change for Monty's savings is greater? And remember, this context, that's where you still seem to struggle. When we took our quiz last week, some of you still did not explain in the context of the problem, what did the rate of change mean, or what did the initial value. You've got to make sense of those numbers. It's not good enough to just say 8 or 6. You've got to go on and say, okay, for Monty, that's Monty earns more money per hour, okay, because Monty's making 8, Ramon is making 6. So Monty makes more money per hour. You can't just say his rate of change is more. What does his rate of change mean? All right, and then number 3 says find the total savings after working 8 hours for each person. All right, so remember, let's set up the equations here. So for Monty, he already had 3, and he's making $8 per hour. So 8 times the hours plus the 3 he already had. Okay. Fixed here. All right, so then if they want to know for the 8 hours, plug it in. So 8 times 8 is 64, and 64 plus 3 would be 67 for Monty. Okay. And then we had Ramon. He was making $6 an hour, and he had $6 in his account already. So if he's working 8 hours, plug in that 8. So 48 plus 6, so 54 would be his total amount. Okay? So Monty's going to have more money. All right, let's look on to the next page. So at the top, number 4, let me adjust my camera here a moment. All right, number 4, it says that the table shows how much money a concession stand earns selling hamburgers. The graph shows how much money the stand earns selling hot dogs. So we got hamburgers and we got hot dogs. And it says, find and compare the rates of change for these two functions. All right, now let's think about this. We've got a table. How do we find rate of change for a table? Remember, it's the change in Y over the change in X. So how much is the Y changing every time? How much is the X changing every time? Well, the amount earned is changing by 8 every time, and the hamburger number is changing by 1. So hamburgers are $8 per hamburger. Okay. All right, on hot dogs, if we look at, remember, change in the vertical, which is Y, over change in the horizontal, which is X. So we're going up 2 units, which is 4, and over 1. So 4 over 1 equals 4. Okay, so he's making, or the hot dogs are making $4 per hot dog. So it says find and compare the rates of change for these two functions. So hamburger is $8. Hot dog is $4, per item. So we are going to make more money selling hamburgers than hot dogs. Okay, that's what we're looking at there. All right, moving on. Number 5, it says 2 companies charge differently for canoe rentals as shown below. What is the rate of change for each function? What is the cost to rent a canoe for 4 hours from each company? All right, now remember, rate of change is always the coefficient of X. So right here, this 8 would be my rate of change, and then here, they don't give it to me as an equation, but they tell you that it's $15 per hour. So if I were to write that as an equation like company A is, I could say that the cost equals 15H. Okay. All right, so it says what is the rate of change for each one? So company A is $8 per hour, and company B is $15 per hour. And it says, what is the cost to rent a canoe for 4 hours from each company? So at company A, we have the cost equals 8H plus 10, and they said 4 hours, so plug it in for H. 8 times 4 is 32, and 32 plus 10 is $42 will be my cost at company A. All right, at company B, it's $15 per hour, so 15 times 4, so my cost is $60 per hour. So even though they didn't have the initial value, the plus 10, some kind of rental fee, they still came out as a higher company to use. Right. All right, let's look on. Number 6, 6 says the graph shows a function. Write an equation with the same initial value and rate of change that is less than the rate of change of the function shown in the graph. All right, so I want same initial value, highlighter, same initial value, and I want a rate of change that is less than the rate of change shown in the graph. All right, so the initial value, remember that's our y-intercept, so that's 1. So we know we're going to have y equals something x plus 1. Okay, something's going to fill in that spot. We know the initial value's got to be the same. So let's check and see what the rate of change of this graph is. So if I'm going to go just from any 2 points, I'll go from this one to this one. So I went up 2 and over 1. So this rate of change is 2. So they said to the rate of change that is less than the rate of change of this function. So I'm going to let you fill in your own number, but it has to be a number less than 2 for you to get that correct. Okay. All right, moving on to the next page. It says to consider the equation y equals x plus 2. Use the equation to complete the table and then graph the equation. Does the equation y equals x plus 2 represent a linear function? All right, now in your textbook notes from Monday, Ms. Hardison got into linear and nonlinear with you, and she did several tables and graphs, so this should be familiar. It says complete the table and graph the equation. So they've already graphed it, but let's go ahead and fill in our table. So they said it was x plus 2. So negative 1 plus 2 would be, okay, fill in that table. I'm going to give you just a minute. So negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And 2 plus 2 is 4. And they have those plotted out. It says the graph is a straight line, so the equation y equals x represents a linear function. And number 1 said, what is the initial value of the function in the example problem, and what is the rate of change? So picking out the IV and the ROC. All right, well, initial value, we said is your y-intercept, so we can pick it out right here on the graph as where it intersects the y, or we can look at it as the plus or minus number in the equation. But 2 is our initial value. All right, our rate of change is the coefficient of x, which is an understood 1, or if we pick it from the graph, it's the up and over, the vertical and the horizontal. So 1 over 1, so 1 is our rate of change. Okay, no problem there. All right, then number 2 says linear functions can be written with the equations in the forms of y equals mx and y equals mx plus b. In which form is the linear function in the example problem? What are the values of m and b, and what do they represent? All right, so we had y equals x plus 2. So does that look like y equals mx, or does it look like y equals mx plus b? Yes, it looks like y equals mx plus b. So we just said in the problem here that the rate of change is 1, so that's what m is. So m is your rate of change, which you'll see we're turning that into our slope. And b is the initial value, which we've been saying is our y-intercept. All right, so m is 1 and b is 2. So just like we picked it out for the IV and the ROC, now we just have m and b. It says, do you think that the equation y equals 2x squared is a linear function, Why or why not? Okay. Then your answer would be no, excuse me, because y equals 2x squared does not fit into, it is not y equals mx or y equals mx plus b. And we're going to also learn later on, because it has an exponent, it is nonlinear. So we're going to go ahead and put that down. That exponents of x are nonlinear. All right. Number 4 at the top says, to graph each of the equations below on the coordinate grid, describe each graph and tell whether or not the equation represents a linear function. All right, so I could make a table to plot some points, but let's use what we know. Okay? So let's start calling it our M and our B. Remember, that's your ROC and that's your IV. So our rate of change is 2. Our IV is 2. So we know that that means we start, because of the initial value, on 2. And 2 as a rate of change is 2 over 1. So from this point, if I go up 2 and over 1, that gives me that next line. Okay? And then I could just connect those. I really should draw more points, but I'm just trying to show you there. Okay. And so, yes, it would be linear. Yes, it is linear. Okay. All right, and then look at y equals x squared plus 2. Now, we haven't graphed enough off of this one for you to see, but no, it would not be linear. Because of x squared. It would actually be a U-shaped graph when we would graph it out. Okay, we could make a table and plot those points, and we'll get more into that in class, but just know because of the x squared, it is U-shaped. It's not fitting into that y equals mx or y equals mx plus b pattern. Okay. All right, number 5 said, which of these equations are linear functions that go through the point 0, 6, and explain your reasoning. Now, remember, when we label an initial value, we've just been saying 2, but I could have also labeled that as 0, 2. So when they're asking you that goes through 0, 6, they're looking for the equations that have 6 as their initial value. So, and they also said linear, okay? So we want the plus 6 going on, so that's good, and that's good. But this one has the plus 6, but it says x squared, and we just said that x squared is a U-shape, so that is not linear. So y equals x plus 6 and y equals 2x plus 6 are linear and intersect the y-axis at 0, 6. Okay, that's what we're looking for. And then that y equals x squared plus 6 is nonlinear. Oops. Nonlinear. And then y equals 6x, that would hit at the origin. Okay. All right, and then the last problem, it says the graph of an equation is shown at the right. Explain why the equation is a linear function, then explain how to write an equation for that function. Well, we can look at it and tell that it does form a straight line. So it's definitely linear. I can pick out my rate of change, or my M. I can pick out my IV, or my B. Okay, and I can write that then in y equals mx plus b form. So let's pick out those pieces. The IV, your initial value, your y-intercept is 3. Your rate of change, remember from any 2 points I can get it, we work from left to right. So if I start here, I would go up 3 units and over 2 units. So my rate of change is 3 over 2. Okay? So I can write this equation as y equals 3 halves x plus 3. Okay? All right, and we'll be practicing still a lot more with writing those equations, but you should be pretty good at it by now. Understand where all those numbers come from. All right, guys, you're doing a great job. Be sure you have both of, or all of the pages in your workbook done and all of the pages done in your textbook when you come back for break, and it'll be an easy 2 100s. Have a great Thanksgiving.